In the chapter 2.4 of our book, page 96, the exercise number 9 says, an intermediate algebra student drives a car at 70 miles per hour. Let D be the distance in miles that the student travels in T hours. First, what I'd like to understand is which one of these is the dependent and independent variable. The hours that pass in a day will not depend on his speed, so that would be independent. He cannot change the hours in a day, so T that represents hours would be independent. His miles, that depends on him, so that would be dependent. We could say that D depends on T. So when the question says, is there a linear relationship between T and D? Explain. If the relationship is linear, find the slope and describe what it means in this situation. Well, yes, there is a linear relationship between T and D because D depends on T. And since there is a constant speed between both of them, there is a linear relationship. Since it also says that he traveled at 70 miles per hour and he did not slow down or he did not go faster, so the slope we can say is 70 because he always traveled at the same speed, which is 70. That would be the slope. Part B says find an equation of the model. We know the equation y equals mx plus b, but we will not be needing b this time. So we could also use, since it says y equals mx, y is the dependent variable, which equals the slope, which is m, times x, which is the independent variable. We could also name it by d equals s times t. I named there that d is the distance, s is the speed, and t is the time. So all we have to do is substitute s, which is the speed, or the slope, which is 70. So the equation will end up being d equals 70 times t.